So last time we did a bunch of examples of things like all humans have one heart, and we did other things where we collected data and so on.
Right.
Where most humans have a heart on the left hand
That's
side.
right. We also did the correlation between shadows and length of shadows and length of
the height
objects.
of the person,
Yeah.
and so on. So that appears to have some sort of things in common, all of
Right.
those. So I believe that's called observational inquiry.
Right, as part of scientific inquiry.
As part of scientific.
Right. So this is going to be scientific inquiry 1.
Observational.
Observational inquiry. We'll deal with the other part later.
Yeah.
Theoretical inquiry.
So we haven't talked about theoretical scientific inquiry so far, but and we'll leave that for a future.
Yeah. So the first question is, what do we mean by observational inquiry?
Okay. Oh, and before that, Tara's back for this video.
Oh, hi Tara. Yeah.
Hi.
Yeah. So let's begin with that question. What do we mean by observational inquiry? Well, in a simple sense, observational inquiry is inquiry based on observation.
Then you have to ask, what is observation?
Yes, okay. What do we mean by observation?
Yeah, what's observation?
So we could include basically experience, right? Experience of a particular kind, sense perception.
Not that I'm experiencing pain or something like that.
No, experiencing the external world, not experiencing
Not
the inner.
my internal state.
Yes.
Yeah.
So if I say something like, I'm experiencing a lot of anger, or I'm experiencing jealousy, that doesn't count as observation.
For you.
Yeah, that is looking inside. Observation means you're looking outside.
Yeah.
But if I say, I see the moon as being bigger than the stars, that's sense perception, that's what I perceive through my senses.
Yeah.
So this is.
But observation is also, so if I'm the person inquiring and I ask, are you angry? And you say, yes, I'm angry. Then that counts as observation.
That's right.
Because I'm the
Because
inquirer.
you are not looking inside yourself,
Yes,
you are
I'm
looking
looking
at the outside world.
Yeah.
No, but
Yes.
isn't that also observation, looking into yourself and observing? Sure, somebody else can't do that. But that's also
So
part of
I think
observation.
that's observation, but not under scientific inquiry.
Right. I think sometimes we will call it introspection.
Yeah.
Looking inwards, okay? That doesn't come under scientific inquiry, introspecting, looking inside.
But my report of introspection
Can be used by
can be
somebody
used-
else.
Right.
That's right.
Yeah, as
As
a
part-
data,
Yes.
as data for
Right.
scientific inquiry. Yeah.
So if I say, I'm experiencing anger, I'm looking inside myself, and I tell Madhav, I'm experiencing anger. And for Madhav, that will be observation, because you say, Mohanan is saying that he's
it's the
experiencing
report
anger.
that is the observation.
That's right,
yeah.
Okay.
Yeah. So this introspecting doesn't come under scientific inquiry. So let me erase that to be on the safe side. But not everything is plain sensory experience, not sense perception. It could include counting.
How about measuring?
Yes, it includes measuring.
If you bring in measuring, then you have to bring in measuring instruments and other instruments.
That's right. Instrumentation. So for example, microscopes and telescopes and so on, weighing machines, all these would come under instrumentation. We may have to do experiments.
That was my question.
Is there anything else that we would?
So don't you use statistics in observational inquiry? That seems like an obvious.
Yes, if you're doing counting and measuring,
Yeah.
quite often there will be variability, and that would mean statistics.
But when you say statistics, statistical numbers, whatever, is that observation or are you going beyond observation? You're doing something to your observation.
That's true. Processing the observation, that's where stats is
Right.
necessary. Yeah. But this will be roughly the kinds of things that will come under observational inquiry. But then, since Sarah raised that question, let's outline the structure a little bit. Okay. So one part of observational inquiry is observing the particular. So for example, I can say, I observe Madhav by measuring his height. And I say Madhav's height is such and such. That's
Observing one
observing.
particular-
And if I say that, it's a report, or I call it observational report. Some particular observation. I could also say Madhav is Madhav's age is such and such. Madhav is male. So height such and such, age such and such, gender such and such.
So at least age you're not really getting from the observation, right? That's a separate
Some documentation.
stuff you've got from
Yeah, but
there.
that's also observational
Okay.
information, data. Okay, data. I could also say weight.
So all of this is your data. What's a data point?
This collection of things about Madhav, this
About one particular
will be data point. Point because it is one particular instance. But if you collect a large number of those, so I can say with respect to Madhav's height, age, gender and weight, and Tara's height, age, gender, weight, and if I take about, let's say, 200 people like that, that will be a sample. Sample is large number of data points. That also comes under observational inquiry. And then you look at, is there a relation between height and age?
So actually, if we just take that height and age, and we put that on a graph,
Yes.
you take a large sample of height and age. You'll see something like, let's say this is height and this is age. You'll see something like, as the age increases, the height increases. Let's put
this
height
yeah,
on.
This is height.
Yeah. And let's put age here.
Yeah.
As the age increases, the height increases fast, then it slows down at some point. Actually, even this is not, it's probably something like that.
Yeah.
And then
goes steady for some time.
And then as you get really old, it kind
Slightly.
of decreases.
That's right. So that will be a
So
line that you are drawing.
You'll have all, with the line that we're drawing is through, you'll have all these data points
Yeah.
of different people,
Yes.
which will kind of mirror this line.
Yeah.
There'll
The
be
line
some,
is drawn through the cluster.
yeah, there'll be some people who are here or
Yeah.
something. You'll have someone who's here, someone who's
Yeah.
down here, but the clustering will come around that.
Right. So this is a line that you draw through the center, but this region
Where
that you
most
have
of
here
the people
is
are.
what indicates that this is the variability
Yeah.
of
So you're ignoring the people who are the complete outliers
yes.
in this.
But at the same time, you also have to specify what's the degree of variability.
Yeah.
So
So you'll say something 95% of people are within
right,
this.
Within this. So when you specify this, that's the degree of range of variability. Sometimes people talk about standard deviation and so on. And that actually is also true about measuring. Except we don't call it standard deviation. We call this inexactness.
Yeah, so I've gone and measured my height using various different instruments.
Right.
And it always comes different. There's
That's
only
right.
1 inch difference here in between different instruments.
Yeah.
Yeah.
Depending upon how you stand,
How
how
I
you
stand.
progress, and so on.
And then sometimes the instruments are also just give different
That's right.
values.
So you have to specify that also. So in scientific inquiry, when you take somebody's height, you have to do it a few times. And then say, this is the range of inexactness, just as you specify, this is the range of, this is the standard deviation. It's exactly the same principle.
Yeah.
So that means all measurements and all such patterns are approximations actually.
Yeah.
Range of inexactness.
Yes. What is the range of inexactness?
So you would say I am 6 foot plus or minus
1 inch. That's right. That plus or minus is the range of inexactness in the measurement.
Okay, so I come at 5 o'clock, plus or minus 5 minutes.
That's right.
Depending on traffic.
Yeah.
Does that fall into the same class?
That will be inexactness. So if you promise to come at 5 o'clock, and if you come at 5, I would
Most
say
people won't get annoyed with
if
that.
she promises to come at 5 o'clock and she comes at 6,
Yeah.
then you will say she's late.
Yeah.
Exactly. That crosses the admissible range of inexactness. So you observe and then you make an observational report and then you get a data point and then you have many data points in a sample. You see a pattern like this,
Yeah.
and then you say that this is true of the population as well.
So this pattern may not be something like this, right? It could even be, for example, the one we did yesterday with all humans have exactly 1 heart.
That's right.
There was no variability.
There is no variability.
It's there.
That is without variability. Then statistics doesn't come in. Every
Sorry.
human has exactly 1 heart.
Before you go further,
Mm-hmm.
what's the relationship between sample and population?
Let's say the population of human beings
Okay.
on the earth,
Uh-huh.
all human beings. But you're not going to collect data on every human being. That's too many, almost infinite. So you take a subset of that. That's a sample that you observe. But then you are also making a statement about what you have not observed.
Yeah.
So to make the statement, every human being has exactly 1 heart, you're not going to examine all the human beings on the earth, people who are going to be born, people who are dead. That's impossible. But you take about, let's say, 1,000 human beings. That's a sample. So Mother was saying that in some cases there is variability. In other cases there is no variability, as exactly 1 heart. There are also, in addition to that, there are also other kinds of interesting things about that pattern that Mother drew, which we mentioned the word correlation, right?
Yeah. And yesterday we had a much simpler correlation between the height and the length of shadows. And it was something like this. Right?
Yeah.
This one seems a little more interesting. That was a straight line.
That's a straight line. So that one is a straight, if it's a straight line, you call it a linear correlation.
Yeah.
This one here is not a linear correlation. So linear correlation and non-linear correlation. When you say linear, it's a straight line. Non-linear means it is not a straight line, it's a curved line. Then there are also, in this case, it goes up and comes down. If it is non-linear, it could be what is called non-monotonic. This looks like a big word, but it's very simple. Monotonic means if this, let's say, if this value increases, it keeps increasing and so on, but notice it's not a straight line, but it keeps increasing.
Yeah.
But here it keeps increasing first and then comes down. So if it does both movements, it will be non-monotonic. This is monotonic.
Yeah. So linear is always monotonic.
Yeah. Either it goes up or it comes down.
Yeah.
Negative correlation, positive correlation.
Yeah.
Okay. But sometimes you have, in this one, you also have this kind of stuff.
Yeah. So the time of day. So if this is this is, or let's say here, this is 2016 summer. This is 2016 winter.
Yeah.
And sorry, it should be the other way around. And this is temperature.
Right. So the temperature goes up.
Temperature
And then comes
here
down?
in the winter is low.
Yeah.
Then in the summer it goes up. Then
Right.
in the winter it comes back down. And in the summer it goes back up.
Right.
And this is your summers and winters. So
Yeah. So as time progresses,
Yeah.
the temperature goes up and down.
Yeah.
That's a wave. So that's a periodic correlation.
Yeah.
So let me write that. This is periodic or cyclic. Even though this is in the form of a wave, it's a cycle, it comes back.
Yeah.
So that's roughly the kinds of correlations that you can get.